Okay, so in this video here, we have a quadratic word problem. So let's go ahead and read it, and then we'll talk about how we're going to set up this problem. It says a landscaping company is designing a rectangular garden that is to be enclosed by a fence. They have 40 meters of fencing available for this project. The area of the garden can be expressed as a quadratic function. What are the dimensions that will maximize the area? What is the maximum area that can be enclosed with the fencing? So they want two different things here. They want the dimensions that will maximize the area, and then they actually want the maximum allowable area based on what they have for fencing available. So how are you going to do this problem? Now, the first key word that you want to look at here is maximize. So for example, I can see that right here, okay? Whenever you're dealing with a quadratic and they're asking for the maximum or minimum, they are looking for the vertex. So for example, if you're dealing with a minimum, you're going to have a quadratic opening up like this here, and it will be at your vertex. And we know that at our vertex, we're going to have some point x comma y, okay? If you are going to have a maximum, it's going to be opening down like this here. And again, that will be occurring at your vertex. And we'll have some point x and y. So we're dealing with this one here because they're looking for a maximum, all right? So think about how can you get this quadratic function and what do we need to do here in order to get that. So let me go ahead and get rid of all this here. I already know that they want me to find the vertex. So I'm going to write down the following formula that you should know. And that is x is equal to negative b all over 2a. This is how we find the x value of the vertex. Once we have the x value of the vertex, we can plug it back in and get the y value. But before we can do any of that, we have to go ahead and derive this quadratic function. So what are they looking for? Well, they're looking for area, right? They want to know what the area is. And they're saying that the area can be represented using a quadratic function. So this one is definitely not obvious, but before you can get the area, you first must know the perimeter. So for example, we know that the perimeter is 40. So I could say 40 is equal to 2L plus 2W. And L and W representing your length and width. And I know that area, right, is going to be length times width. So think about how you can derive a quadratic function based around length times width using the perimeter that you have right here. Well, to make this perimeter equation a little bit easier, if you divide everything by 2, you're going to get the following. You'll get 20 is equal to L plus W. Again, dividing all of my terms by 2, I'm balancing out the equation. That's fine. I can rewrite it like this. And so think about if I solve for either L or W here. It won't matter which one you solve for, but if you solve for one of them, I'll solve for L, I can then substitute that in to this part right here. And then I'll have everything in terms of either L or W, okay? So for example, if I solve for L, what do I get? I'm going to get length is equal to 20 minus W. And then I'm going to take this L and plug it into this part here. And that's how I can represent the quadratic. Because remember, they're telling me that the area of the garden can be expressed as a quadratic function. So if I'm dealing with a rectangle, I do length times width, that's going to be my quadratic. And so what is that going to look like? Well, it's all going to be in terms of W, right? So I'm going to say area is equal to, I'm going to have 20 minus W, that's my L, times W. And there we go. So area is going to be equal to 20W minus W squared. Okay? And if you really, really want to get fancy here, you can say the following. You can write it in function notation. You can say area is a function of the width. And that is going to be equal to 20W minus W squared. So in other words, when I plug in width, I'm going to return the area here. All right, so what do we need to do from here? Well, again, they want the maximum, okay? And there's two different parts they want here. They want to know the dimensions that will maximize the area, and then they want to know the actual maximum area that will be allowed based on what you have for fencing. So you have to find the vertex here. And then we'll talk about what each value means of your vertex, okay? So to find your vertex, you're going to use this formula right here. All right. And so I'm going to say here, x is equal to negative b. Now, what's my b? Well, here's my quadratic. Okay. Remember, ax squared plus bx plus c. My b is 20. So I have minus 20 all over 2 times a. What's my a? Well, my a is this negative 1 in front of w squared. So I'm going to do 2 times a negative 1. That's going to give me negative 2. So my x value here is going to be 10. Now, what is that actually representing? What does that 10 mean? If you go back to your quadratic right here, and we wrote it in function notation, when I plug in the width, I'm going to get the area. So your input is like your x value here. So the x value of the vertex is representing the width, okay? And remember, this is where the maximum is going to occur. So I know that the dimension for my width to get the maximum area has to be 10. And so if I want to know the length now, all I have to do is take this 10 and plug it into this equation right here where I see a w, because again, 10 is representing w. So 20 minus 10 is also going to give you 10. So those are my dimensions. My width has to be 10, and my length has to be 10 in order to maximize the area. Okay, that's part 1. So I'm going to go ahead and box that in. Part 2 is pretty simple because now you actually have your dimensions. So there's a couple of different ways you could do it. You could simply just do length times width. 10 times 10 will give you 100. So, right, you're going to have 100 meters squared. That's going to be the maximum allowable area. But another way you could do it, since we know that this 10 is the x value of my vertex, if I simply just plug this 10 into my quadratic function, wherever I see a w, I'm going to get the maximum area. And if we're writing that in function notation, you can say a of 10 is equal to 20. Now here's my w, I'm going to put 10, minus 10 squared. So what do you end up getting here? Well, you get a of 10 is equal to 20 times 10 is 200. And then 10 squared is 100, so minus 100, and we get 100, right? So it doesn't matter how you do it, either way will work. So my area here is going to be 100, and this will be meters squared. That will be the maximum allowable area, right? And again, these are dimensions here, so we should put the units. These are meters, right? And there we go. All right. So I hope that you found that video helpful. I hope that you gained something from it. Just remember, if you're dealing with a quadratic and they're looking for the maximum or the minimum, they are essentially looking for the vertex. From there, you just have to differentiate what the x value of the vertex means and what the y value of the vertex means. Once you do that, the problem becomes pretty straightforward. So again, I hope that you found the video helpful. I hope that you gained something from it. If the video did in fact help you, if you could just go ahead and give it a thumbs up, that would be greatly appreciated. Also, make sure you subscribe, that way you get more math videos in the future, and I'll see you in the next one.